Hello, Maurieo! Maurieo does Q&A on Land Surveying Worksheet LS054, CROMBIES Link Travis. Hello! In this video, I'm going to answer some questions sent to me by a student. I'm pleased to be doing this because questions are the lifeblood of teaching and learning, in my opinion. So when people send in questions, I try and answer them as best I can. They're a sort of window into the people's learning, a window into where they're at, what they understand, and quite often and as you may find out in this, they highlight some shortcomings in the initial instruction, so they help to perfect things for everybody. So let's get on and have a look at this. So first of all, we need to look at the question, and let's get it up back. So I do not understand the meaning of put the biggest bearing correction on the shortest line. Could you please explain it? And what is the method to get adjusted bearings? Now, as you can see here in the red in that, I've put a number of little bits of red there, and they indicate some little errors and perhaps points of clarification. So the first thing to notice here is that this has got through to the end, and their observed bearing on their, what I assume is the closing line, 43, 42, 52, is some 23 seconds less than the what I consider would be the published bearing between those two marks, 143, 43, 15, 23 seconds. So there has been a slight error, it would appear, made, in that it's come in at 21 seconds rather than 23. Now, as you'll see, that is not going to make too much difference, just apart from the annoying fact that it is very, very slightly inaccurate. And quite often, especially in circumstances like these, we do use accuracy as a way of controlling things, so that if things work out nice and smoothly, we know that we've got the arithmetic right. So what's happened here is then the 23 seconds is there's been they've set it, there's four angles, it would appear. There's an angle here, or set up 1, 2, 3, and then one up into here. 4 angles. Okay, so there would be 4 setups in this particular job. I think 4 setups, 1, 2, 3, 4. And okay, at 23 seconds, you can apply so much at each angle. However, what we find is that shorter lines, a minute of correction on a shorter line can be the same as a second of correction on a longer line. So say, for instance, if we take a so what we do is the 11, say we put a 10-second change on this line here, 10 seconds on that line there. What effect will that have? Well, it's the way to work that out is to go 0 degrees, 0 minutes, 10 seconds equals, and that's our answer, equals, and just to take the tan of that, so go tan of the answer, which is 10 of the answer, and then times. So if we go 41.82 equals, we get 2.2. So that's actually millimeters, because that's times 10 to the negative 3. But let's just go shift mode 6, and we'll just go into 3 decimal places. Okay, so that's 2 millimeters. So 10 seconds over 41.82 would have a subtend an arc of 2 millimeters. However, if we go for a longer line, 10 seconds, clear. So let's go answer equals, oh, that's not going to work for us, 0 degrees, 0 minutes and 10 seconds equals, if we go tan of that, tan answer, and we multiply that by, say, 90.66, we can see that it's going to have, although it's still only 10 seconds, it's going to be a much bigger error. So we can see that proportionally the error is small, for smaller in the shorter lines. So in the shorter lines we can put a bigger error and it's only a small amount. So whereas the 41.82 10 seconds was 2 millimeter error, in 90.66 10 seconds was 4 millimeter error. So we can put more error into the shorter lines and it will have less overall effect. So this is what we do. We put more error in the shorter lines because in the scheme of things it's not going to have the same effect. It's not going to move things around that much. Whereas if we put say 10 seconds in the 90.66 meter line, it's going to have twice the effect that it will have in the 41.82 meter line. It'll result in a 4-second change in the 90.66, whereas it would only be a 2-second change in the 41.82. So as a rule, we put a bigger bearing correction in the shortest line. Or that's one method of doing it. We are dealing with very small bearing corrections. I tend to just keep them quite even, and if the Travis lines are pretty much of similar length, just keep it the same. But we can, particularly for very short lines, we can put quite a lot of error into those lines because that's more likely where it's going to be. And this also tells us that when we're traversing, we try to keep the lines as long as possible, or particularly round about the same length. So we don't want some very long lines and then one very short line, because the very short line can have quite a big effect on our bearing accuracy. So hopefully that's explained a little bit as to why we can put the biggest bearing correction in the shortest line. Now, in terms of this, what's happening here with this reduction, it's a little bit different to what I have been doing previously, and that is that it's gone through and calculated incorrectly a 21-second misclose. It should be 23, and then it said, right, well, I'm going to put 10 seconds of the error in these two shorter lines and 1 second in the longer line here to give 21. Well, it should actually add up to 23. So I'm going to assume that it's put that this is a longer line in here, and I'm just going to put 2 seconds in that line. However, the bearing correction accumulates up to the 23 seconds, and that hasn't been shown here particularly well. But what's happened here is we've got 336.0616 plus 10 seconds gives us 336.0626, so no problem there. But here we've got 53.0127 plus 01, but we should add the 10 as well, because that's included in this, so when it comes around it'll add. So that should be 11, and now you can see 53.0127 plus 11 gives you 53.0138, which helps with that. And then we've got here 126.0027, and that will have to add all of them. It'll have to add 10 plus 1 is 11, plus 10 is 21, and that's where we get 126.0048. Now what I've also done here is added in another 2 seconds just to make everything fit with the numbers that we've got, and we can see we've got 42.52 plus 23, which would give us 43.15. So a bit of an error there. That should be 23, and the correction should be a 10, a 1, a 10, and a 2. Okay, possibly not how, there are other ways of doing this, but remember it's the correction is to the angle, and rather than the bearings come from the angle. So that's plus 10 seconds, and then that'd be plus 11, 21, 23. Okay, so I'm hoping that that's given a little bit of an idea of what's going on there, and just sort of worked out a few problems. Now let's move on to the next question. I do not understand the bearing rounding table. How to round to get the data in the table. So here's the table here, and this goes back again to what we had with the little calculator. So what you'll find is that if you take if you take lines under 50 meters, a 1 minute, if we went the tan of 1 minute, so if we go 0 degrees 1 minute equals 0 degrees 1 minute equals, and take the tan of that, tan, and then multiply that of tan of the answer, and multiply that by 50 times 50 equals, we get 15 millimeters. So in terms of bearings, if we round them to the nearest minute and they're under 50 meters, they're going to be within 15 millimeters. So that's fine. Now if we then say, well, let's look at sort of under 50, over 50, and under 100. So let's look at 100 meters, see what happens there, if just for 20 seconds. So if we take a minute, let's just look at 20 seconds, 0 degrees, 0 minutes, 20 seconds equals tan answer equals times 100 equals, we get it's only going to be 0.010 or 10 mils. So if we round anything between 50 and 100 to the nearest 20 seconds, we're only going to be 10 mils out, or 10 mils of error. So that's sort of similar, 15 mils at 50 to the nearest minute. And then if we go over 100, let's go, or let's see what happens at 500 mils if we go 10 seconds. So let's just click tan 0 degrees 0 minutes 10 seconds times 500 equals 24 mils. So to the nearest 10 seconds, anywhere up to 500 would be 24 mils out, which, it's not, it's sort of, they're all in around the same ballpark. So I mean, you can get exact numbers on these. So if we went 500, if we went 5 seconds, so let's go 10 0 degrees 0 minutes 5 seconds times 500 and we get 12 mils. So, you know, so what we say is, you know, we try and keep the air around about the same, around about a 10 mils or of that order, but 5 to 10 to sort of 20 mils. And if we round bearings to the nearest second, to the nearest minute, sorry, up to 50 meters, that's not a problem. It's not going to make too much difference. If we round them to the nearest 20 seconds between 50 and 100, that's not going to be a problem. If we round them to the nearest 10 seconds between 100 and 500, that's going to be all good. And anything over 500 meters, just to the nearest 5 seconds. And this is all to do with the tan of these angles and how much they subtend. So that is my explanation and my answer of the questions that was be submitted by the student. So yeah, thank you for, you know, putting your questions in. I hope that it's clarified the situation for you. However, if it hasn't, you can always ask more questions. Feel free to ask more questions. Cheers! See you